Here's a very interesting maths question that was given to students sitting the IB high-level maths exam in 2017, and this was question 7 from paper 1. So we're dealing with a curve which is defined by this equation, which, as you can see, is not an explicit equation in terms of y, and we're given the graph for it. And the question is, what are the coordinates of this point here, of point P, which satisfies the property that the tangent line to point P is parallel to the y-axis, okay? So one way to do this is to consider the first derivative. Now, normally we would be used to thinking about the first derivative as dy by dx, and in this case, it would be that dy by dx at p should approach infinity, right? Or the derivative should be equal to infinity, rather. But just to avoid infinity, we're gonna try to solve this problem from a different angle. Namely, we're gonna look at dx by dy. Okay, and if we look at dx by dy, then the derivative of x with respect to y at point P is going to be 0, and we're going to use this to find the coordinates of point P. Okay, so let's do some implicit differentiation of that equation that is given to us, which is x cubed plus y cubed, and then we have minus 3xy equals 0. Okay, so if we differentiate everything with respect to y, okay, this is what we have. We're going to have 3x squared and then dx by dy. So we're applying the chain rule, right? We're differentiating the power, and then we're differentiating x with respect to y, and then we have plus 3y squared, and then we have minus 3 times, and x, y are both functions of y, so we have to apply product from here. So let's do that. We have dx by dy multiplied by y plus x times dy by dy, and this is equal to 0. Okay, now of course dy by dy is just 1, so we can write this as 3x squared dx by dy, and then plus 3y squared minus 3y dx by dy, and then we have minus 3x is equal to 0. Okay, so what we're actually interested in is dx by dy, so we can factorize dx by dy, and this is what we get. We have dx by dy times 3x squared minus 3y equals 3x minus 3y squared. And as you can see, we can just cancel out the 3's just to simplify the equation a bit. And then we have dx by dy equals x minus y squared over x squared minus y. Okay, so this is the derivative of x with respect to y. And if we make this, if we put the condition that this is equal to 0, it will give us that x will be equal to y squared. Okay, so knowing that x equals y squared is the condition for the derivative to cancel out, we will use this and we'll plug this into the equation of the curve. So instead of x, I'm going to write y squared. Okay, so let's write the equation again. Actually, we have x cubed, and then we have plus y cubed, and then we have minus 3xy equals 0. Okay, so instead of x here, I'm going to replace it with y squared. So it's going to be y squared raised to the power 3. So it's going to be y to the power 6 plus y cubed minus 3, and then we have y squared times y equals 0. Okay, which gives us that y to the power 6 minus 2y cubed is equal to 0. So we can factorize the y cubed, and that gives us y cubed times y cubed minus 2 is 0. So there are two solutions for this. The first one is y equals 0. And if y equals 0, then according to this, then x is equal to 0. So this tells us that xy equals 0, 0 is a solution. And let's actually look at the graph and understand what's happening. So we're actually looking for point P here, but at 0, 0, we have the tangent to the graph is actually parallel to the y-axis. It's actually the y-axis itself that's tangent to the graph. So it's a valid solution, except it's not the solution we're looking for. We're looking for another place on this curve where the tangent to the curve is parallel to the y-axis, and the only other point is here. In other words, we're looking for another solution, or for the second solution of this equation. And if this is not the solution we're looking for, although it's a fine solution, then the only other thing is y cubed minus 2 equals 0. Okay? So that means y cubed is equal to 2, which means y is equal to the cube root of 2. And if we know y, then we can find x, and x is y squared, so x will therefore be the cube root of 4. So point P has coordinates given by the cube root of 4 and the cube root of 2. So if we draw those here, this is the cube root of 4, and on the y-axis, let me just get rid of this. On the y-axis, you have this point as the cube root of 2. And those are the xy coordinates of P, and that's the end of the question.